Yeah, good evening everyone. My voice is audible? Hello. Yeah, okay. Shall we start the session?
That's Suresh. We will wait for 2 more minutes and we will start.
Okay, okay, sir.
Yeah, good evening, one and all. So, is my screen visible for you?
Yeah, visible, sir.
Yeah. So, in the extra desk class, we have seen the case statement. Okay. So, case statement we have seen in the extra desk class. So, it is a multi-branching statement. The case statement executes a multi-way branching. So, where every bit of the case statement or every bit of the expression that is present in the case contribute to the branching decision. So, that means if you are writing here the expression A here, so every bit in that expression will be referred to the branching decision. So to do which or to execute which branching. Okay, so the statement has two variants. Okay, so where the sum of bits of the case expression can be selectively treated as don't care. Okay, so for example, if you want to write a program for the priority encoder. So the priority encoder, what we do, for example, if you take a 2x4 priority encoder, so for a for a 4x2 priority encoder here. So what you can do? So this is I3, I2, I1, and I0 are the inputs, and outputs are Y1 and Y0. So these are the inputs and these are the outputs. So for example here, if I0 is equal to 1, so if I0 is equal to 1, so that is why I am giving the priority to the line I0 here, and I don't bother about I3, I2, and I1. Okay. So if I0 is my priority line, then the output will be 0, 0. So if I1 is my priority and I0 should be 0, and I3 and I2 can be high impedance or don't care state. So therefore the output is 0, 1. So if I2 is equal to 1, so the priority input is I2, I1 and I0 should be 0 and Z should be don't care. Okay, so in this case, so the output will be 1, 0. So similarly, if my priority is I3 line and I2, I1 and I0 may be 0, 0, 0, so therefore the output will be 1, 1. So if you want to write program for this here, here what happens is that, so here I3, I2 and I1. So in this case here, so we have I3 is equal to ZRX, I2 is equal to ZRX, I1 is equal to ZRX. Okay. So what happens here? If you use the case statement here, the case statement will not work. Why? Because the case statement doesn't know the value what is Z and what is X. Okay. So in these statements, if you want to write the with the undefined states or with don't get states, if you want to define the case statement means, so we have the two cases here. So that is case Z statement and case X statement. Case Z and case X. So where case Z allows us to where case Z allows to treat Z as don't care. Okay, so it allows Z to treat as don't care, and moreover here you can use question mark in the place of Z also. Okay, so here when you use the case X here, so the case X are also uses as don't care here. So here also you can use question mark instead of X. Okay, so you can use Z or X for defining the don't care combinations here. Okay, so if you are using the don't care combinations, we have to use case Z or case X. Okay, so that we have to remember. So simply if you use the case statement means your program will not be executed. So apart from this, so the everything, so that is the programming and everything will be the same. So now let us write the program for this priority encoder by using the case Z statement. Okay, now here module priority encoder. So the output is Y and the input is I. So 1 minute. Yeah. So now we have to define the inputs and outputs separately. So now define input 3 down to 0, since it is a 4-bit, 3 down to 0 I. So similarly output 1 down to 0 Y. So when you are defining, the output in case of procedural assignment statements, so we have to make sure that, so I have used the register. Okay, so register 3 down to 0, sorry, register 1 down to 0 Y. Okay, so define the output in terms of register in the registers in the procedural assignment statements. Okay, so next after that, so I have to use the always statement, always at the rate. So when my output will change, whenever there is a change in the input. So therefore always at the rate of I. Okay, so apart from, there are no other variables which can change the output Y. So always at the rate of Y. So after that begin the always block. So case case Z. So here the expression is I. Okay, so with respect to the I am going to set the output. So with respect to the inputs I, so my decision, my branching decision will take place. So therefore case Z I here. So what is the first condition here? 4 dash B Z Z Z1. Okay, so Z Z Z1. So if the condition is 4 dash B Z Z Z1, so what is the output? So the output, that is output Y is equal to, so the output Y is equal to 0 0, that is 2 dash B 0 0, that is a 2-bit binary number whose output is said to be 0 0 0. Okay, next. The next condition is, so if the input I is 4 dash B Z Z 10, So then the output is regarded as 0 1, that is 2 dash b 0 1. So if the input is 4 dash b z 1 0 0, so the output is regarded as 2 dash b 1 0. Okay. So next, if the output, so if the input is taken as 4 dash b 1 0 0 0, so therefore the output is 2 dash b 1 1. Okay. So next, so I have given all the cases with regard to the condition here. So therefore, so end case. So after the end case, next end the always statement. So after that, end module. So this is the program for priority encoder, or it is a program for case x and case z statement, where x and z are the undefined things here. Okay, so these are the undefined variables here. So if you are using the undefined variables, so you should make sure that you are using the case x or case z statement. So simply using the case x will not make you to execute the program. Why? Because so these case x, so these case x and case z statements will only able to see or whether if the given input is don't care or not. Okay. So next, after that, now let us see about the if else constructs. Okay, so if statement and if else construct. So the next one is regarding the if and if else construct. So let us see one by one here. So the if construct checks a specific condition and decides the execution based on the result. Based on the result. Based on the result. So if you see here, the usage of that is the syntax of simple if statement. So there will be some assignments here. So that is the assignment statements will be there. So after that, whenever you use the condition, okay. So if condition, so you should not worry about the assignments that are before the if statement. Okay, if condition, so if the condition is true here, what happens is that, so the assignment which is given under this will be executed. Okay, assignment 2, assignment 3 and assignment 4. So these statements will be executed. So after the execution of the statement 1 here, the condition is the condition specified is checked. So whether it is true or false. So if the condition is checked here, the immediate assignment, that is assignment 2, will be executed. Otherwise, the next statements, that is assignment 3 and 4, will be executed. So the execution of assignment 2 only depends upon the condition here. The rest of the sequences will not depend upon the if condition. Okay. So if the condition is true, automatically the assignment that is next to that will be executed. Otherwise, so the statements will not be executed. Okay, otherwise the statements 3 and 4 will be executed. Okay, so this is a simple if statement that we can able to see. So coming to this, so the next statement is if else construct here. Okay, so the next one is if else construct. So here, so you take the assignment. So after that, if condition begin, so assignment 2, assignment 3, else so else assignment 4, assignment 5, and assignment 6, like this. Okay, so if you see here, what happens is that after the execution of the statement 1, so once the statement 1 is executed, the if condition will be checked here. Okay, the condition 1 is satisfied here, then the statements which are in between the if condition, that is the statements which are present after the begin statement of your if condition will be executed. So a small mistake. We end here. Also here we have the begin. Okay. So for begin. So similarly, if the condition is false, means the statements which are present under the else will be executed. That is, the assignments 4 and 5 will be executed. So if the condition is true, means the state assignments 2 and 3 will be executed. So if the assignment is false, means the statements 4 and 5 will be executed here. Okay. If there are multiple statements to be executed, if the condition is true, then only we have to use the begin and end. Otherwise, there is no need to use. Okay, so if the condition is executed, so after that there is only one statement that has to be executed, means there is no use. There is no need to use the begin and end. If there are multiple statements here, then only we have to use the begin and end. So otherwise, just you can use only the assignment directly. Okay. So now let us see. So in order to execute, in order to use the if statement here, so let us see a small counter here. How you can define a counter by using the if statement, if statements. Okay. So here now I want to design a 4-bit counter here. I want to design a 4-bit counter. So it is a 4-bit up counter for suppose. So here I want to design a 4-bit up counter. So as we have seen in the previous classes, the counters initially starts from 0, 0, 0 to so it has to count every time by 1. So next step it becomes 0, 0, 1. Next step it becomes 0, 1, 0. So after that, so 4-bit no. So it is 0, 0, 1, 0, 0, 1, 0. So after that 0, 0, 1, 1. So like this, the counter will be incremented by 1. So when the count reaches 1, 1, 1, so the counter has to be resetted again to 0. So it is the up counter, and we have to design this up counter by using the if statement. Okay. So here, what is the condition? Here the condition is that, so initially I have to assign the counter to 0, 0, 0. So initially I have to assign the counter to 0, 0, 0. So after that, based on the condition, that is, if the count is equal to 1, 1, 1. If the count is equal to 1, 1, 1 means I have to make the counter to 0. Count to 0. Otherwise, I have to increment the count. So it is the logic that is present here. So now let us see how you can do it. Okay. So module. So example of if statements. Okay. So here the output is while and the input let us take as the clock here. Okay. So input define it as clock and the output is y. So which is a 4-bit counter. So that is 3 down to 0 y. So after defining the output states here, so next is define the output in terms of registers. So register 3 down to 0 y. So next, initially I have to assign the counter to 0, 0, 0. So therefore initial. So initial here, what happens is, so initial y is equal to 4 dash b 0, 0, 0, 0. So now I have initially assigned the counter value to 0, 0, 0. So next, always at the rate of clock here. So which clocks I want to start the counting only with respect to the positive edge of the clock. So therefore, with respect to the positive edge of the clock, that means, so whenever the clock changes from 0 to 1 transition, so the statements which are written under this always block will be executed. So always begin. So now what is the condition? If y is equal to, if y is equal to 4 dash b 1, 1, 1. If y is equal to 4 dash b 1, 1, 1. So what happens here? If you see the syntax here, so if condition, so if condition, so after that begin the if statement. So if the condition is true means, then what should happen? Y should become 4 dash b 0, 0, 0, 0. Okay. So the counter has to be assigned to initial state, that is 0, 0, 0, 0. Okay. So Again, after that, what happens? So first what you have to do is that, so end. Okay. So next else. So if that condition is false, if the condition is false means, so we have to go for y is equal to y plus 1 dash b1. That is, the counter will be incremented by 1. Okay. So after that, next you can see the syntax here. So after that you can go for the assignment. So that is end the always block, after that end module. So if you see in the program here, so in the else statement I have not used begin and I have not used end. Why? Because so since there is only one statement here, so there is no need to use the begin and end. If there are multiple statement means we can use the begin and end here. So that is the important thing what you can see here. Okay, so this is the program for the counter. So whenever the program executes, what happens? Initially the counter value becomes 0 0 0. So for the next clock pulse, so for example, initially the counter becomes 0. Okay, the count value will be 0 here. So the count value will be 0 initially. After that, or else simply what you can take is that, so it is y of 3, y of 2, y of 1, or y of 0. Okay, so initially the counter value is taken as 0. Okay, so this is the clock input. Okay, so next, whenever the clock comes from 0 to 1 transition, okay, so up to this the clock will be output will be 0 0. So whenever the positive edge of the clock here, what happens? It will check. So what is the value of count? So y, that is the output. So y is 1 1 1. So it is not true. So therefore it goes to the else here. So else condition, in the else what you have written, y is equal to y plus 1. So therefore the value of y will be incremented. So therefore the value of y becomes 0 0 0 1. So therefore y naught becomes 1 here. Y naught becomes 1, and all the things again remain as 0. Okay, so next, so again after the next clock pulse, what happens here? So the count will become increment by 1, it becomes 0 2. So therefore it becomes 0 0 1 0. So now y1 becomes high here. So y2 and y3 will be the same. Okay. Similarly, after the next count again, it becomes 0 0 1 1. So therefore, at the next clock pulse here, what happens is that, so y0 becomes 1 and y1 will remain in the 1 and y2 and y3 will remain as 0. So this is how the counter works. So for the program which you have written using the assign statement. Okay, so that is the using the if else statement here. Okay, so similarly, now let us see how you can write a small d program by using the if statement here. So that is a small d flip flop by using the if statement here, if statements. So here take a D flip flop here. So it is a D flip flop. So it has two out input D and it has clock. So apart from this, so it is the clock signal. So which is the symbol of this is nothing but which is the positive edge clock here. That is a positive triggered flip flop. So here we have the clear and preset. Okay, so also assume that this flip flop is having the clear and preset. That means if clear signal is activated means whatever the data present in the flip flop that will be made to 0. If preset is activated means the data will be set to 1. So the flip flop has two outputs, that is Q and Q bar. Okay, so it is the D flip flop. Now write the program for this. So module. So DFF D flip flop. So outputs. What are the outputs? Q bar. The outputs are Q bar. Next. So we will take the Q bar after using the assignment statement. So let's take only one output here. So Q is the output. The inputs are D, clock, clear, preset are the inputs. Okay. So after that, specify the outputs and inputs separately. Input D, comma, clock, comma, clear, comma, preset. So output is Q here. Okay, Q is the output. So declare the output as register. So register Q. So the next one is always at the rate of positive edge of the clock. Okay, so now here the output changes with respect to the positive edge of the clock, as well as the output may change whenever you change the input value D, that is data input D, or else when you would change the input clear, when you press the clear or when you press the preset, the output may vary. So therefore you have to yeah, add all these under the always statement. So whenever the clock changes, that is whenever the clock during the positive edge of the clock, or whenever the D input changes, or whenever the clock, that is sorry, whenever the clear changes, or whenever the preset is button changes. Okay, so whenever the changes happen here, so what happens is that begin, so the statements under the always clock should be executed. Okay, so the first condition is if what happens if clear is equal to, that is if clear is equal to 1 means what I can take is if clear. So here it is the expression. So clear is the expression. So if clear is equal to 1 means what happens, the data in the flip flop has to be set to 0. Okay, so therefore Q becomes 0. So clear means whatever the data in the flip flop, that must be cleared to 0. Okay. Next, so there are multiple conditions here. So therefore, I am using the if else if. Okay. So else if else space if. Okay. So next I have to go for the preset. Okay. So if preset is equal to 1, what happens? Q is equal to 1 dash B1. So if clear is equal to 1 means the data output data has to be set to 0. Okay, if it is not the case of condition, so next I have to go for the else if statement. Else if, now I have to check preset. Okay, if preset is equal to 1 means Q has to be set to 1. So if it is also not the case means the last case is whatever the D input value is there, that must be assigned to Q. So therefore else Q is equal to Di. Okay, Q is equal to Di. So next I have to end the always block and end module. So this is the program. So for this program, so next, okay, so I have to write the test bench. So how you can write the test bench for this program here? The first one, if you want to write the test bench for this, so module test bench. So what are the inputs here? So the input should be declared as register. So register D comma clock comma clear comma preset. Okay. So again the outputs of your main module should be declared as while in terms of your test bench. Therefore while output as Q. Next, instantiate your top level module. So my the program for the module for which I am writing the text bench is DFF. So the DFF. So then followed by the instantiation name. So then followed by the list of port names. So that is Q comma D comma clock comma clear comma preset. Okay, so follow the same order. So after that, I have to initialize the input. So initial begin. So what are the inputs? So clear. Okay, so clear is the one input here. Okay, so clear is equal to, so clear is equal to, okay, so at 0 instance of time, clear is equal to 1. Okay, so clear is equal to 1 dash B1 colon, that is semicolon. Preset is equal to, okay, so preset is equal to 0 dash B1. Okay, and clock is equal to 1 dash B1. Okay, 1 dash B1. Next, DI, that is data input, is equal to 1 dash B1. So like this, I have to specify all the inputs here. Okay. So now when you are giving the test bench, we have to make sure that you should not give both the conditions on at the same time. So then you get the error. So when you are writing the test cases, so you forget about the logic that is written in the main program. So the logic in the main program is that, so the clock, the clear and preset should not be active at the same time. Okay. So any one of that should be only active at the same time. So if you are making the both the clear and preset active here, what happens is that it will take only the thing related to clear. Why? Because since the clear is first checked here, you may get the output here, but so when you are giving the preset is equal to 1 also, the output will be 0. Why? Because if you are giving clear and preset is equal to 1 at the same time, the first condition here, that is clear, will be executed. Okay. So that is the problem in some cases. So in some cases, depending upon the standard of Verilog, it may get also the output as undefined or high impedance. Okay. So next I have to give the after 2 instance of time here. So after 2 instance of time, so I may able to vary the inputs. Okay. So again after 2 instance of time, so take clear is equal to 0, b 0. So preset is equal to 0. Sorry, 1 dash b1, 1 dash b0. Okay. So clock is equal to 1 dash b1. Okay. So next D is equal to 1 dash b1. So like this, we have to specify all the port names. Okay. So after specifying all the valid input combinations, so I have to end the initial statement. So after ending the initial statement, in order to print the output, I can use the display command or a monitor command, which I have seen in the previous classes. Okay. So the next statement. So this is about the a simple introduction about the if statements. Okay. So once all the syntaxes are finished, we can design or we can write more programs. We take a simple program of once all the syntaxes are finished, what we can do is that, so we will take one program and we will try to write the same program by using all the syntaxes or all the constructs. Okay. So the next construct what you have in the behavioral modeling is that, so assign, deassign construct. The next construct which you are having in the Verilog is assign, deassign construct. A behavioral block here is activated at the beginning. A proper action. So here the assign, deassign statements allows continuous assignments in a behavioral block. So what we have seen so far in the behavioral model, only we are using the procedural assignment statements. Okay. But by using assign, deassign construct, so it allows the continuous statements within the behavioral block. So for example here, always take the following statements: always at the rate of negative edge of the clock, so x is equal to y. So it is the statement here. Okay. So when we are executing this at the negative edge of the clock, that means whenever the clock comes from 1 to 0, that is whenever there is a 1 to 0 transition of the clock, the value of y is assigned to x. Okay. The value of y is assigned to x, and the value of x remains frozen. The value of x remains frozen at that particular value until the negative edge of the clock. Okay. So the value will be frozen until the negative edge of the clock. So for example, if you take a clock here, so it is the clock and it is the x value here. So it is the x value. Okay. So it is the x and it is the clock. Now if you see the output, so when the clock comes from 1 to 0, so at this point here, so what is the value of x? The value of x is 0. So therefore at the negative edge of the clock, the value of that is the value of y, this is x. The value of y will be assigned to x. Okay, so therefore the x value becomes 0. So now if you see here, until the next clock pulse, so until the next negative edge of the clock, even though the value of your y changes, the output will not change. Okay, so next, at the next negative edge of the clock, what is the value of y? The value of y is 1. So therefore, at the next negative edge of the clock, the output, that is the x value, goes to 1. So similarly, next at the negative edge, so up to this, the value of x will be taken as 1, even though the y value changes in between. So the x will not be affected, its value will be frozen until the next clock, that is the 1 to 0 clock transition. At 1 to 0 clock transition, the value of y is taken as 0. So therefore the output goes to 0 until the next transition. So like this, you get the output, that is the output for using the statement always at the rate of negative edge of the clock, x is equal to y. So now consider one more statement here, always at the rate of negative edge of the clock, where now you can, x is equal to y. Okay, so now what happens here, at the negative edge of the clock, the value of c is the value, that is the value of x is assigned to the value of y in a continuous manner. That means if there are any changes in the y, means they are directly referred to the value of, sorry, here I have to use the assignment statement. So assign x is equal to y. So first what happens, at the negative edge of the clock here, the value of y will be assigned to the value of x. Okay, so now whenever you make the changes in y, automatically these changes are reflected to the value of x. Okay, so they will not wait for the until next edge of the clock. Okay, so in between the clock transition, if there are any changes, means automatically the changes will be assigned to x. Okay, so for example, if you take the same here, so it is the clock, so this is y here, so this is y, so this is y. So now if you see the output x here, so initially what is the value of sorry, this is clock, so the value of x will be assigned with y. So since we are using the assign statement here, so therefore the value of x, y becomes x. Okay, so at the next clock pulse, what happens, when the clock is coming from 0 to 1, the value of y is taken as 0, so therefore it is 0. So in between the next clock transition here, so that is in between this clock transition, in the previous case, even though the input has changed, the output doesn't change. But if you are using the assignment statement, means, so automatically the input changes. So as the y becomes 1 here, the x also becomes 1. Okay, so at the next clock cycle, that is the negative edge of the clock cycle, what happens, the value of y is 1, so therefore the value of x is assigned as 1. Okay, so immediately after the clock transition, the value of y becomes 0, so therefore the value of x also becomes 0. So like this, the output will be changing. Okay, so you can say that this will be like a direct connection, that is like a direct electrical connection from x to y. Okay, so this is how you can do it. For example, if you want to remove this assignment, means, so you can use the deassign statement. Okay, so if you use the deassign statement here, automatically what happens is that, and you have to give that at deassign x, means, so the value of the x will be deassigned and the value of x will take in the output of y as previous case. Okay, so this is the thing what we have to remember. So now let us see a small example of assign statement here. So let us see a small example of assign statement. Okay. For example, take a multiplexer. So take a mux 2x1 multiplexer. So a 2x1 multiplexer has one selection line here. So or else take a 4x1 multiplexer. The 4x1 multiplexer has two selection lines, that is S0 and S1. So again it has four inputs, that is I0, I1, I2 and I3. So it has one output. Okay. So if the selection lines are 0, 0 means, so the input line I0 will be connected to the output. If the selection lines are 0, 1 means the input line I1 will be connected to output Y. If the selection lines are 1, 0 means the input line I2 will be connected to Y. If the selection lines are 1, 1 means I3 is connected to the output Y. So this is what we have to write the program, that is the behavioral program. So now how you can write by using the assign statement is module. So module mux 4x1. So what is the output? Output is Y. So the next inputs are selection line, that is S3 here. So I can use the selection lines S3, sorry, S comma I. Okay, so now define this separately. So input 1 down to 0 S, input 3 down to 0 I, output Y. Okay, so next here what happens? So declare the outputs in terms of register. So register Y. So after this, so use the always block. So here always at the rate. So here what happens? So here the output will change whenever there is a change in the selection line. So therefore, yes. So even there are inputs here, that is I3 to I0. So even though this input line changes, there will not be any effect on the output. So therefore, always at the rate of yes. What is the first condition? If selection line is equal to 2 dash b 0 0, if the selection line is equal to 0 0 means what happens? I have to assign the output. So I have to assign the output Y is equal to I of 0. Okay, so directly I am using the assignment statement. So here what happens is that the value of Y will be assigned to, that is the value of I0 will be assigned to Y. Okay, so here normally we can retain the program without using the assignment statement also, but why we are using the assignment statement is that, so in between, okay, so if the selection line is 0 0 for some time, and if the value of I0 changes at that particular time means automatically that I0 will be assigned to Y. So for example, initially the I0 value is 0. So at the when S is equal to 0 0, if the value of I0 becomes 1, automatically so Y becomes 1. So after that, so it next I have to go for one more condition, that is, since there are four conditions here, I can use if else statement, if else if statement. Else if, what is the statement? If S is equal to 2 dash b 0 1, okay, so then I have to assign Y is equal to I of 1. Okay, so next one more condition is there here. Else if S is equal to 2 dash b 10, if F is equal to 2 dash b 10, so assign Y is equal to I of 2. So else, so apart from these conditions, you have to assign Y is equal to I of 3. Assign Y is equal to Y of 3. So here we have to use the begin statement. So end module. So end module. So here we have to use it. So it is how you can write a multiplexer statement by using the assignment statement here. So like this you can write the values of assignment in case of a multiplexer program. Now let us see, in the previous case we have used the D flip-flop. Okay, so now write the D flip-flop by using the assignment statement here. So how can you use the assignment statement? Let us see here. So the D is the input for the D flip-flop, and we have the clock, that is now you can go for the negative edge of the clock. So you have the clear, you have the preset, so you have the output Q, and you have the Q bar. So where Q and Q bar are opposite to each other here. Okay, so now if you want to write the program, so module DFF. Okay, so the what are the outputs? The Q bar are the outputs. So where Q and Q bar are opposite to each other. So after this clock clear, the clock D clear, preset. Okay, so these are the inputs. So after this again define the inputs and outputs separately. So input clock D clear preset, output Q comma Q bar. So next declare the outputs as register. So register Q comma Q bar. Okay, so register Q comma Q bar here. So next what is Q bar here? So Q bar is the opposite of Q. So therefore here I can use the assignment statement here. So assign Q bar is equal to negation of Q. Okay, so Q bar is equal to negation of Q means, with respect to the assignment statement, means whatever may be the value of Q. Okay, whatever may be the value of Q, and in a particular condition, so Q may be 0 or 1, so it is always the Q bar will be always the opposite to that of Q. So that value will be assigned to the QB. So next always at the rate of clock, always at the rate of clock, or preset or clear, always at the rate of clock or preset or clear. So begin the always statement. So begin if clear is equal, if clear, that is if clear is equal to 1, assign Q is equal to 1 dash B naught. Okay, so next, else next here if. Okay, so or else I can use the else if statement. Else if. Okay, so else if so here I can write the program in two ways. Okay, so let us see that here how I can write the program in two ways. So else if preset. Okay, if preset is equal to 1, so what happens here? So assign Q is equal to 1 dash B1. Else if it is not the case here, so else if what happened? Pause. So pause edge of the clock. Okay, so pause edge of the clock. So what happens here? Q is nothing but D. Okay, so after that end the always block, assign Q is equal to D, end the always block or end the module. Okay, so this is the one way of writing the program here. So the other way of writing the program is that, so here what I can use the two always blocks here. Okay, so I can use the two always block. So in the first always block I can use only clear and preset. So begin if clear is equal to 1, assign Q is equal to 1 dash B0, else if preset is the condition, means assign Q is equal to 1 dash B1. So else D assign Q. So now the Q value will not be assigned in any of these case. So here end the always block, and here again always at the rate of positive edge of the clock. So you give as Q is equal to DI. Okay. So next end module. So this is another way of writing here. Okay. So here it is the synchronous assignment here. So it is the synchronous assignment. So without referring to the clock, we are assigning the values of Q. So in the first always block and in the second always block, I am going for the synchronous assignment. So that is the synchronous value of DI is assigned to Q. That is with respect to the clock. So this is the way of writing the D flip flop by using the assignment statement. So apart from this, in the tomorrow session, so we will see how to write a for loop and while loop in the tomorrow session, and also we will try to see how you can write a addition program. So how we can write a addition, that is addition program by using the for loop and while loop, as well as we will see how you can design a some counters by using the while loop and for loop tomorrow. Okay. So this is all for the day. So I will hand over the session to Suresh.
Yeah, thank you, sir. If you have any queries, please ask me. Otherwise, sign out this session. Okay. Hello, sir. Hello, sir.
Suresh.
Some students are asking please introduce some software tools, sir. Some software tools. Can it we
Yeah,
are
yeah.
using now TAN and gelling. I like that.
Once the theoretical part is finished, so the theoretical part will be done in this week. Okay. So once the theoretical
Okay.
part is done, so we will go for writing of the programs. So for various things, that is the various digital design examples. So after that, each program we will execute. So whatever we have seen, the various statements here, that we will execute in the model sim and we will simulate that and we will see the differences.
Okay. Thank you, sir. If you have any queries, participation, you have any queries? Yeah. Thank you. Sign out. Sign out. No, sign out the session. Thank you.
தங்களை விட உயர்வானவர் என்று எண்ணி தவறு செய்திருக்கேன். ஆனால் உண்மை என்ன தெரியுமா? நீங்கள் இந்த முழு பேரண்டத்தில் இந்த உலகத்தில் சஞ்சரிக்கும் ஒவ்வொரு சம்பவங்களும் உங்கள் விருப்பப்படிதான் நிகழ்கிறது.